Hi everyone, I'm Jiarui. I will be presenting our work on implicit personalization in language models, a systematic study. This work has been accepted at EMNLP 2024 findings. Let's start with a brain teaser. What color is a football? So now the question might have different meanings depending on the cultural context. And for instance, if the word color is spelled in American English, COLOR, the answer might be a brown football. But if it's spelled in the British way with an OUR, the answer might be a black and white football. And interestingly, we see similar results on Google. When queried with American and British spellings, Google provides different sets of images reflecting this cultural context. So this leads us to the underlying phenomenon of implicit personalization. And there's a distinction between implicit and explicit personalization. So implicit personalization relies on subtle cues on the input to infer the user's background without explicit user introduction, while explicit personalization involves explicitly stating user preferences or details. And therefore, the goal of implicit personalization is to infer the user's background based on their input and then customize the response accordingly. So we first want to ask, does implicit personalization exist in language models? But we will first illustrate our formal definition of IP with the example of asking about the color of a football. So given the question as input and whether the person is British or American as a background, and the model's answer to the question as a response. The model will infer user background from the input question and then generating a response tailored to that inferred context. And to formalize this, we use a causal graph where like each nodes are interconnected, and we aim to understand how much of the background B influences the response Y. So to answer the question about the existence of IP. Implicit personalization can manifest in multiple ways. From like cultural adaptivity to potentially negative forms like discrimination or creating echo chambers. Despite its significance, there hasn't been a standardized framework to study IP comprehensively. So our presentation is structured into three parts. So first, we will introduce a formalization of the concept of IP, including causal graph formulation, as mentioned before, and hypothesis testing frameworks. And then we will dive into experiments on 3 case studies. And finally, we will discuss further suggestions for addressing IP in models. So first, to evaluate the existence of IP, we model the response generation process of IP with a causal graph G, which models the cause and effect relationships among a set of random variables V, and through the edges E as the causal links. To answer one of our key research questions, does IP take place in larger models? We formulate it as a question of causal inference. Does user background B have a causal effect on the response Y? So if Y is a real number, then we can calculate the average treatment effect, ATE, of B on Y by directly intervening on B. So this estimates the expected change in Y. But a challenge in our study is that Y may not be a real number, but instead in the text format as a response of a larger model. So what will we do in this case? We will first focus on the distributional change between the paired responses to model the causal inference, but also controlling the semantics. So this is how we check the existence of a causal effect. To assess the significance of the existence, we can use different statistical hypothesis tests for different variable types of the effect. So for example, for response Y in raw text, we first use a similarity measure to evaluate the similarity between the responses. And then the null hypothesis proposes that the median of the similarity is at the predefined level M0. And we then define the alternative hypothesis H1, and we quantify the difference in this way. And we use a sign test to obtain the test statistic. And another example, like for responses coming from rating scales, which are discrete and constrained within certain bounds, we will employ a permutation-based test. Since direct intervention on the inferred background variable B is challenging with current interpretability techniques, we will instead adopt an indirect intervention approach. And this involves generating varied inputs that maintain the same semantics, but differ in subtle background markers. So for example, we could generate input versions with both British and American English spelling, which only diverges in B, but keeping the same semantics as, then compare the generated responses. And we introduce a moral reasoning framework to evaluate the ethical implications of IP. We will consider the three perspectives. Consequentialism, does it bring more benefits or harm? Deontology, does it violate any laws or regulations? And contractualism, does users and other people consent to or agree with its use? So this will help assess whether implicit personalization is ultimately good or bad. So we conducted 3 case studies to detect and understand IP. Each case study explores different aspects in terms of the existence and whether IP is good or bad. So these are the 3 case studies. The first case study focuses on cultural adaptation. So here we explore whether large language models can infer a user's cultural background based on subtle cues like spelling or word choice. And note that this is positive for the user because the tailored response can enhance user satisfaction by providing more accurate or desired answers. And for this, we developed a dataset called Amber QA, which contains both objective and subjective questions framed in both American and British English contexts. So our findings show that models such as GPT-4 exhibit implicit personalization by adjusting their responses to match the inferred cultural backgrounds. Our second case study investigates the quality change of educational content generated from different user groups. So this kind of IP is bad for users because we don't want the models to have bias when facing or interacting with different people. And we examined these variations of English, such as African American English, English as a second language, and Standard American English. And we analyzed whether language models generate lower quality responses for certain groups. And we perform style transferring of the original essay prompt Q into different prompt styles. So we collected the essay prompts from GRE and TOEFL exams, and here's an example of different essay prompt styles. And our findings indicate that most models do not show a significant disparities except for the Alpaca model. And in the third case study, we explored the echo chamber effect, where models may reinforce users' incorrect beliefs and tend to amplify this kind of misinformation when answering other questions afterwards. And here we see a trade-off between user satisfaction at the moment and the long-term effect on the user and society. We use a dataset called farm, consisting of questions where a user's past exposure to misinformation was indicated. And we examined whether larger models are more likely to provide incorrect answers after being primed with misinformation. So we found that most models demonstrate significant echo chamber behavior, except for GPT 3.5 instruct. So based on these three case studies, as a conclusion, we proposed a workflow for future development of language models to handle IP. So this involves detecting whether IP is happening, evaluating its ethical implications, and applying targeted strategies for improvement. For example, where personalization is desired but absent, we could fine-tune models using or like use our techniques to increase their sensitivity. But in contrast, in cases where personalization is harmful, we could apply techniques to neutralize background effects or increase interpretability. So thank you for your attention. For more details, please refer to our paper, which is available on arXiv, as well as our code and datasets on GitHub and Hugging Face. And we welcome any questions or discussions about this work.